This recording is for in class 82, which is part of Standard 19, Equations of Circles. Today's focus is going to be on learning what the standard form equation of a circle looks like, and then using it to graph or using clues about a circle to write that equation. The equation of a circle has a lot of different parts, so make sure you're copying carefully. The first part is going to look like x minus h inside parentheses squared plus the second part is y minus k inside parentheses squared, and then all of that is equal to r squared. So there are two variables in this equation, x and y, which will stay as variables, but the h, the k, and the r will all be replaced by numbers that represent different features of the circle. To figure out what those represent, we're going to look at a circle investigation so that you can see a circle equation in action, and then we'll see if we can come up with some ideas about what the h, the k, and the r represent for that circle. So if we look at this circle that I have available here, that general standard form equation of the circle is sitting right here, ready to be used. Right now, the h and the k are set up as being zeros, and the radius is set up as being 3. So we see that from the center point out is a 3, and then we've got this circle that's centered at 0, 0. So it looks like the h and the k, since those are both set at 0, are giving us the center of the circle, and then this r, radius value, is showing up on the other side of the circle, but it's being squared. If we investigate the specific equation for the circle that we're looking at, that also looks to be the case. X minus 0 would just be x squared, y minus 0 for the center of the circle would just be y squared, and then 3 squared for the radius of the circle would be 9. So if we pop back over to our notes page, when h and k are both 0, that circle is centered right there at 0, 0, at the origin of the circle. So just remind ourselves that that's the origin of the graph. And we can fill in at the top then that our h and k values are going to be the center of the circle, while the radius is going to be represented by r. So a couple of other things to investigate here as we get started with these equations. The first thing we're going to look at is what happens when h is changed to a positive number. So if we look at our h slider up at the top, if I change that and I make it positive, notice that that circle seems to be moving to the right, which makes sense. If h gets bigger, we think about bigger horizontally as being moving to the right. But something surprising happens down here in the equation. That h is positive 5 right now, but in the equation it's looking like a minus 5. So there are some things to be careful of with the equations of circles, because what you see in the equation is not the full picture of what's actually happening on the graph. When h is positive 5, it's going to look like a negative 5 in that equation. So the direction that the graph moved would be right, but the equation is going to look like x minus h still, and then we'll have our y squared and our r squared to finish out that equation. You can probably guess what's going to happen next, but we're going to investigate it just to be sure. Let's look at what happens when h is changed to a negative number instead of a positive. So if I move this back here to 0, we're back at the origin now. If h becomes a negative number, sure enough, that circle is going to move to the left like we would expect it to. But if we go down here and investigate the equation, again, it looks like the opposite of what we're expecting. That center is at negative 6, 0, but we see a positive 6 in the equation. That positive 6 is coming from subtracting a negative 6. Subtracting a negative changes to be adding a positive. So, what direction did the graph circle move? H was negative, we would expect it to move to the left, and it sure did. But what was unexpected is that equation ended up looking like a plus sign, because when we subtract a negative value, a negative number, that simplifies. When that h is negative, it ends up looking like we're adding a number. In this case, it was a 6, so I'm just going to plug a 6 in there so we don't get too confused with our general standard form of the equation. Okay, we'll do more work with that opposite thing that we're seeing when you're in class tomorrow. If that's confusing, don't worry, we'll do some more work with that. But when we move 6 to the right, it looks like x minus 6 squared in the equation. When we move 6 to the left, it looked like x plus 6 squared in the equation. Let's investigate our k quickly and see if that does the same thing or something different. If I put my h back to 0, just so that we're back at the origin, if I make the k positive, it moves up. That's probably pretty expected. Looks like a positive 5 in that center ordered pair, but then again, it looks like a minus 5 in the equation. What happens if we make that k negative? It moves down like we would expect. The center becomes a negative y value, but then look at that. That equation looks the opposite of what we expected again. So at least it's consistent. When the graphed circle is dealing with a positive k, we're going to be moving up. And when we have a negative k, we're going to be moving down. But we're going to end up then with equations where it looks the opposite. So if we moved up 6, it's going to look like a minus 6 in that equation. And if we moved down 6, it's going to look like a positive 6 in that equation. Now that we've made our way through the introduction for in class 82, we're going to go ahead and look at some examples of the types of questions that you'll need to answer on your assessment for this standard. So taking a look at these first two examples, we are being asked to graph the circle. And then as part of that, we're also going to be asked to list the circle's center and the radius before we graph to make sure that we're making decisions wisely. So if we think about all of those things that we just investigated, we know that we're going to have to work carefully when we're looking at these h and k values. They are going to tell us about the center of the circle. However, they look the opposite of what they actually accomplish. So when this looks like an x minus 1, that's not going to send us to the negative x values. It's actually going to send us the opposite direction, which means the x value for the center will be a positive 1. When we look at y plus 3, that's not going to send us to the positive y. It's actually going to send us the opposite direction to a y coordinate of negative 3 for our center point. And then remember, when it comes to the radius, we talked about how this part of the equation is actually r squared. So we have r squared equal to 4, which means we can square root and figure out that our radius will be positive 2. So to graph, we're going to start with the center point. We're going to move 1 to the right and 3 down. That's what our h and k tell us to do. We're going to use our radius of 2 to move out to the right, to move straight down, to move to the left, and to move up. And then to the best of your ability, you're going to sketch in a circle that connects those 4 points. And try to make it look as round as you can, but it doesn't need to be perfect. As long as you have your center and those 4 points and it looks like you tried your best to sketch through those exactly, that's what it will look like to graph a circle. Looking ahead at number 2, this one is also in standard form. So when we're looking at the negative 2 and the positive 1, we're looking at clues about the center of our circle. Remember, they look like the opposite of what they are, though. So if that's a negative 2, our x-coordinate will be positive 2. And if that's a positive 1, our y-coordinate will be negative 1. This value is r squared. So for our radius, we want to square root 16. Our radius will turn out to be 4 this time. So starting us off at a center of positive 2, negative 1, we're going to count 4 units this time. So 1, 2, 3, 4 boxes to the right, 4 boxes down, 4 to the left, and 4 up. And the larger the circle is, the more difficult it is to make it look like a circle. So really take your time and try to sketch carefully through each of those 4 points and try to round it out as well. All right, go ahead and switch to the next page and we'll continue some examples. The rest of our examples are going to be about using information provided to write the standard form equation of a circle. And we can use the graph if we need to, but it's not required for these problems to have the graph. So I feel like in number 3, if they're giving us the center and they're giving us the radius, that means we have our h, we have our k, and we have our r. So perhaps writing down the general form of the equation would be a good place to start, but I don't really feel the need to graph that information because if h is 0, I can just plug that in, x minus 0 squared. And if k is negative 6, y minus negative 6 will turn that to look like a positive 6. And then on the other side, I've got my radius squared. We do want to make sure that the standard form of the equation is simplified if it needs to be. So we will always simplify our r squared. 5 squared is 25. We won't simplify if there's a binomial that's being squared, but if we're adding or subtracting 0, we will simplify that to just look like the variable squared. So this just becomes x squared plus, and then y plus 6 in parentheses squared for the general, or for the standard form equation of that circle. Number 4 is a little bit trickier because we're not given the center and we're not given the radius. So this might be an opportunity where our graph could help us. The clue that we have here is that the ends of the diameter are at 9, 4. So that's actually slightly off the graph, but that's okay. And negative 1, 4. So if we connect that, what we're looking at is the diameter. Well, if you think about the diameter, your center should be exactly in the middle of that segment. And since that segment is perfectly horizontal, we can count into the middle to figure out where that center point is. We think about moving 1, 2, 3, 4, 5 units to the middle there. That spot is going to split up that diameter perfectly on the left and the right. Another way of doing that is to use what's called the midpoint formula. I'll show you that on a different problem later on where it's not quite as easy to count. But if you have a straight horizontal or a straight vertical segment, the easiest way to find that center point is just going to be to count into the middle. That ordered pair for the center looks like it's turning out to be 4, 4. Both the x and y values are positive. Now the other detail that I'm going to need to find out to write my equation is the radius. Again, since this is horizontal, we can just count that distance. This is also a way to confirm that we actually found the center point. The distance on either side should match. The radius turns out to be 5. So if we take the h and we take the k and we plug it in to our standard form equation, that's going to look like x minus 4 squared plus y minus 4 squared equals 5 squared, but I'm just going to go ahead and call that 25 so that I don't have to write it all out a second time to simplify that r squared. All right. Example 5 is another situation where we have the endpoints of a diameter. So if we sketch this out, the first endpoint is at 6, 3, 6 to the right and 3 up. And the next endpoint is at negative 6, negative 7. So that diameter is not horizontal and not vertical. If we go ahead and we sketch that diameter in, we can't count diagonally with much accuracy. So this might be an opportunity for us to use what's called the midpoint formula. This will be given to you on your assessment resource card to use. Basically, what we're going to do is average the x values and average the y values to find the x and y value that's in the middle of that segment. And that's going to help us track down our center point. So if we look at our two x values, we would be taking 6 plus negative 6. Adding a negative is just like subtracting. And then our y values would be 3 plus negative 7, so 3 minus 7. Sorry, I'm not sure why that was a 0. Should be a 2 on the bottom. I think my brain instinctively knew what was coming next. 6 minus 6 is 0, and 0 divided by 2 is 0. So the x-coordinate for my center is 0. 3 minus 7 is negative 4, divided by 2 is negative 2. And sure enough, it does look like 0, negative 2 right there is on my diameter. Another way that you might think about that is by thinking about dividing this up into a couple of triangles. So if we think about moving from one point to the other, I drew that in a kind of an awkward order, but we started here. So our rise and our run, which is slope related, could help us out as well to find the middle. If we're going down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total, to make it to the center, that means I would just go down half as much. 1, 2, 3, 4, 5. And if we're moving over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to the left, that just means from that spot, I would move over half as much. 1, 2, 3, 4, 5, 6. So right there, at that same 0, negative 2, we could track down that value. That might also be a helpful way to help us find our radius. There is an official distance formula that you can use to find your radius, but a lot of us are pretty good at Pythagorean theorem, so we could also create a little right triangle out of that distance of 5 and distance of 6. We're looking for the radius, which is a distance here, so those negative signs for direction aren't really important. The radius squared would be equal to 6 squared plus 5 squared. And unlike a typical Pythagorean theorem problem, I'm not actually going to simplify this all the way. Because if I can figure out what r squared is equal to, 61, that r squared value is actually what I need for my equation. So we could just stop there. X minus the x-coordinate of the center needs to be squared. Then we're going to add y minus the y-coordinate. Subtracting a negative is like adding. And then that's equal to r squared, which is 61. X minus 0 can be simplified as x squared. And that's one way we could go about the work of finding our center and finding our radius. There are lots of other ways. So maybe I'll try to show you some of those other ways as we go through the other examples. So midpoint formulas, or using triangles, using Pythagorean theorem, some of the options you have for finding those missing values. Okay, our next example looks like they're giving us the h and k value again because we have the center. I'm going to go ahead and graph that at negative 2, positive 5, left 2, up 5. But then the next clue tells us about a point that it passes through. 3, 0 would mean 3 to the right, but not up at all. So if this is the center, and this is a point that the circle passes through, I'm not going to draw the whole circle, but connecting the center to the circle itself is a picture of the radius. And so another option, when you have the center figured out, so whether you're halfway done with the problem or they just give it to you, is to go ahead and get that plugged in to the standard form of the equation. X minus h would be minus negative 2 plus y minus k would be y minus 5. Both of those are squared and then added together. That's equal to r squared. So we could, again, use distance formula or draw in a triangle to find our radius using Pythagorean theorem. But the circle equation is really just a Pythagorean theorem equation in disguise. So it's also possible to use the official circle equation to finish this out. We think about this as an extra x and y value. We can replace x in this equation with 3 just for a moment, and we can replace y in this equation with 0, again, just for a moment. Everything else just gets kind of copied down. And then what happens is r squared is the only variable left in this equation. So we end up combining like terms inside the parentheses first, 5 squared, plus negative 5 squared. If it's negative, keep it safe inside parentheses. 5 squared and negative 5 squared are both 25. And so we've actually just used the circle equation itself to track down 50. We'll revisit what we had already started working on with the h and the k substituted in. But then r squared now is 50. So we can use that to finish out the equation of the circle. So lots of different options for how you can track down the missing pieces. Again, it's not that Pythagorean theorem wouldn't work. In fact, if we were to draw our little triangle in here to think about Pythagorean theorem, we would get exactly what we got here. This distance is technically negative 5, and this distance is positive 5. So those are the exact values that we ended up running into when we were using our circle equation. Just like Pythagorean theorem, we would get the same answer. All right, 2 questions to go. Number 7, again, gives us that center point and gives us a point that we're passing through. So if you want to, you can visualize that. 6, negative 3 is the center. Negative 3, positive 9, slightly off the graph, would be a point that it passes through. So then remember, since we're passing through and this is the center, that big long segment is going to be the radius. X minus h will look like x minus 6, that gets squared, plus y minus k is minus negative 3. And then we don't know our r value yet, so we need to find it. I'll go ahead and find r the third way on this problem so you can decide whether or not you like it. You can use the official distance formula, which will be listed on your assessment resource page. And that distance formula requires you to plug in your 2 ordered pairs that you want to find the distance in between. And then we do some subtraction and some squaring. So if we were using the distance formula, x2 would be negative 3 minus x1, so minus positive 6 will stay looking like subtraction. Back to y2, that's 9, minus y1, minus that negative will end up looking like plus 3. We're going to simplify inside those parentheses, so negative 9 plus 12. Go ahead and square both of those, 81 plus 144. Add them together, square root of 225, which in this case is a perfect square, and that distance turns out to be 15. Now remember, that's the actual distance from the center to the circle, so that's the radius. So when we plug it back in to get that standard form equation of the circle, we're going to have to do 15 squared, which then needs to be simplified to arrive at our official final answer for the equation of this circle. So now you've seen 3 different methods for how you can find r. All right, we have one more problem to finish out our last notes page of the entire school year. So for the ends of the diameter, we're going to graph 3 to the left and 4 down, and then 2 to the right and 4 up. Again, if that's the ends of the diameter, we know that our center point is going to be halfway in between those 2. So we can use that midpoint formula to average the endpoints and figure out what's in the middle. Or you can use a triangle method if you prefer to set that up. The 2 x values are negative 3 and 2. And the 2 y values are negative 4 and 4. So this is actually a great example of why it's a good idea to know the midpoint formula. If we're averaging negative 3 and 2, we're going to get negative 1 over 2. So that is a fractional center value, which you wouldn't necessarily figure out if you're not super careful with the graphing. So negative 1/2, forgot my negative sign at first, is going to be the x-coordinate. And then 0 for the y-coordinate will give us our center point. From there, I'm going to use the method where I plug in my center. So x minus negative 1/2 will actually look like x plus 1/2 squared. Y minus 0 will just be y squared. And then r squared is something I don't yet know because I don't have the radius. But I'm going to use the same method that I used up on example 6, where I'm going to take information from one of the endpoints. It doesn't matter which one, so I'm going to choose this one that has all positive values and plug it in for the x and plug it in for the y. So what that's going to do is it's going to give me the ability, using a point on the circle, to solve for what that r squared value should be. So my x coordinate and my y coordinate come from any point that's on the circle. This is going to be 2.5 squared, which is 5 over 2 squared, become 25 over 4. And then 4 squared is 16. If we add those together, so 2.5 squared as decimal would have been 6.25, plus 16 is going to give me 22.25. This is a little bit strange because that means that my r squared value is a decimal. That doesn't usually happen, but r squared is what I need to finish out my equation. So I've got x plus 1/2 for the h value, and then y squared, since my y value is 0, equal to 22.25. I forgot that my y coordinate was 0, so I'm actually going to clean that up just a little bit before I call it my final standard form equation. Just plus y squared, and then equal to an r squared value of 22.25. We won't normally have decimals like that, but they are possible. That just means that that circle doesn't quite have an integer radius or an integer value for both of its center point values. All right, that's it for your last notes of the year. Thanks for watching. We'll see you back in class.